A 55-meter long chain hangs vertically from a cylinder attached to a winch. Assume there is no friction in the system and that the chain has a density of 11 kilograms per meter. Use 9.8 meters per second squared for the acceleration due to gravity. How much work is required to wind the chain onto the cylinder using the winch? How much work is required to wind the chain onto the cylinder if a 55 kilogram block is attached to the end of the chain? Okay, so we're given this formula. Work is this integral. It's the integral of force from A to B. Okay, so let's see how this is solved. Okay, so the first thing we need to figure out is well, we have 55 meters of chain, and this function says that it's force of the remaining length of chain after y meters have been wound onto the cylinder. Okay, so if we start with 55 and we are pulling up, then the length of the chain remaining is going to be 55 minus y. Okay, so that's the remaining chain, the length of remaining chain. Okay. Um, we also need the density of the chain in our force function, and we're given the density of the chain, which is 11 kilograms per meter. So we'll go ahead and put the 11 out front and multiply through. So that will give us 605 minus 11y. 605 minus 11y. Okay, one final thing that we need for a force function is, in this case, gravity. We have gravity, and we're given that it's 9.8 meters per second. Okay, so we have all that, and now we need to go ahead and integrate this thing using this formula right here. So W is going to be equal to, from A to B, so 0 to 55, of 9.8 times 605 minus 11y dy. Okay, now we integrate this. We can leave the 9.8 out front. We would get 605, well, let's write the 9.8 out front, 605 minus 11y squared over 2. Okay, and that's going to go from 0 to 55. Okay, if we plug our limits in and subtract, we should get 163,047.5 joules. Okay. Now our second problem, we're asked to put a 55 kilogram block attached to the end. Okay, so it's not too hard to do this since we're already actually going to have half the work. All we're asked to do is the same thing except add on 55 grams, or 55 kilograms, excuse me. So our function would be the following. Work is equal to, we'll call this work 1 and work 2 because we had part A and B. It's still 0 to 55. Okay, and we still have the 9.8 times the 605 minus 11y. But we're now also going to have plus 9.8 times, what was it, 55. Okay, so all of that is going to be dy. Now, we've already got the answer to this. It's this 169,000 joules. So all we really need to do is the second part of the problem. So the 55 dy would need to be integrated. So we'll keep this separately, and we'll say that this is 169,047.5. So we really only need to add in this part. So let's say we have, I'll write it over here, 0 to 55 of 9.8 times 55, that's times 55, dy, which is equal to 9.8 times 55 y from 0 to 55. Okay, that's going to, when we plug those limits in, that's going to give us 29,645 joules. Okay, so we add those two things together, and second. I think this should have been a 3. Apologize for that. So it should be 163,000, not 169,000. So let me write that. 163,047.5. And this other one is 29,645. So when we add those together, 163,047.5 plus 29,645, we'll get a total of 192,692.5 joules.